It really feels like everywhere you turn these days, it's all about data, data, data.
Yeah, for sure.
But, it strikes me that the real challenge isn't just having the data itself. It's understanding how it all fits together.
Right, exactly.
It's like having a million puzzle pieces, but no picture on the box.
Totally.
And so today, we're diving into a field that's tackling this exact challenge head on.
Okay.
This incredibly powerful combination of graph technology and artificial intelligence.
Yeah.
What's becoming known as graph AI.
Graph AI, very
Yeah.
cool.
So for this deep dive, you were kind enough to share this really in-depth report analyzing, well, kind of the whole landscape of the graph AI market,
Right.
where things stand now, and even more exciting, where things are headed.
Yeah, absolutely. I mean, I think the goal here, right, is to really pull out those golden nuggets, the most valuable insights from this analysis,
Yeah.
and then try to explain those fundamental mechanisms that make this technology tick,
Oh.
and really illuminate why it's becoming so crucial, in the whole evolution of AI.
Yeah.
Want to break it down, make these complex ideas clear, and show you why graph AI is so relevant.
Exactly.
It's not just some abstract concept,
Right.
It's really at the cutting edge of what's happening.
It is.
Yeah.
All right. So let's get down to the nitty-gritty here. When we use this term, this phrase graph technology,
Yeah.
what are we actually talking about?
Right.
I mean, even the name itself sounds kind of,
It sounds a little abstract.
abstract, yeah, a little bit.
So at its core, graph technology, it's a mathematical framework, really.
Okay.
It's for representing connections between things. So imagine a network,
Okay.
right, made up of individual entities, we call those nodes, and the relationships that link them together.
Okay.
And those are the edges. Now, these basic principles, they've been around in mathematics for centuries, but they're now proving so valuable in AI because they offer this natural, intuitive way to model the intricate web of relationships.
Okay.
It exists in so much of the data we're dealing with today.
Right.
Okay.
So that's the graph part.
Right.
Now, AI, we all have a general idea, but for this conversation, how are we defining artificial intelligence?
Right. So broadly speaking, AI, it's about creating machines that can mimic human cognitive abilities, right?
Okay.
So learning from data, solving problems, making decisions. And traditional AI has had amazing success in lots of areas.
Yeah.
But when it hits data, where the value is all about the interplay between different elements, it can struggle,
Okay.
right, to grasp that full picture.
Gotcha. Okay.
It misses those subtle dependencies.
So this is where it gets really interesting.
Yeah.
As we swim in more and more interconnected data,
Right.
those limitations of traditional AI, they become super apparent.
Absolutely.
And that's when graph technology takes center stage.
Right. Steps into the spotlight.
Yeah.
That's exactly it. The scale, the interconnected nature of data today, it's mind-blowing, right?
It is.
Think of social networks, the Internet of Things, even biological systems. It's intricate. And that's made graph technology, essential for pushing AI forward. So initially, incorporating graph algorithms into machine learning, it was kind of gradual. Early machine learning, it was designed for more structured, like spreadsheet-like data.
Right.
But as the web and social media exploded, those connections, they became undeniable.
Right.
And then we had those early wins, like Google's PageRank algorithm back in '96, a brilliant demonstration of how analyzing links between web pages, you could unlock incredible insights
Right.
about their importance. But it was those more recent breakthroughs,
Right.
like Deep Walk in 2014, that really ignited things. And then you had graph convolutional networks, message passing neural networks coming on the scene.
Okay.
And those techniques, they allowed us to directly apply neural networks to the graph structure itself, learning from the connections in a way that previous methods just couldn't,
Right.
leading to a much more powerful AI.
Okay, so we've got the foundation laid. Now, let's dive into some of the ways graph AI is actually being used today. Where are we seeing this tech have a real impact?
Okay, so one of the most recognizable applications is in recommendation systems.
Okay.
You know, how platforms like Amazon, they suggest products you might like, or Netflix recommending movies and shows. Graph algorithms are working behind the scenes there,
Okay.
really analyzing those relationships between users and items. They build a graph
Okay.
where users and items are nodes, and then your interactions, purchases, views, likes, become the connecting edges.
Okay.
And by spotting patterns in those interactions, The system can find users with similar tastes and recommend items others have enjoyed. And this isn't just a cool feature.
Right.
It directly drives sales, improves user engagement, making it a huge application for revenue generation.
It makes perfect sense, right? Because Graph AI, it can surface these insights that might otherwise be completely invisible to traditional data analysis methods, right?
Right.
You buy a specific type of coffee maker, Amazon sees that other people who bought that same coffee maker also bought these specific coffee beans.
Right.
Boom, suddenly those beans are in your recommendations.
Exactly. It's all about mapping those connections.
It is. What's another key area where this is proving its value?
Another one is fraud detection and prevention.
Okay.
So fraudulent activities often involve coordinated efforts across networks. And graph analysis, it really shines at mapping these complex relationships.
Okay.
So you've got transactions, users, accounts, all that stuff.
Okay.
For example, with insurance fraud, you might have individuals who seem unconnected.
Okay.
Maybe attorneys, medical providers, auto repair shops, right? But they're actually part of this loosely connected criminal ring.
Oh, wow.
And by visualizing those connections as a graph, fraud detection teams, they can spot those suspicious patterns, anomalies that traditional methods just miss.
Okay.
And what's really noteworthy is that Graph AI offers a level of explainability,
Right.
unlike some other black box AI approaches.
So you can actually see the connections.
Yeah, you can trace them.
Understand why something's flagged as potentially fraudulent.
Exactly.
That explainability factor, that seems super valuable, especially in industries with lots of regulations like finance, right?
For sure.
What other kind of unexpected uses are we seeing pop up?
Well, drug discovery and development.
Okay.
That's a field that's undergoing a big transformation thanks to Graph AI.
Okay.
You know, biological systems, they're inherently complex, right? You got genes, proteins, drug molecules, all interacting.
Right.
And graph technology, it offers this powerful way to model these intricate biomolecular structures and their relationships. Researchers can represent genes, proteins, drugs as nodes, and then their interactions as the edges.
Okay.
And then they use graph algorithms to identify potential drug targets and even uncover new links between existing drugs and different diseases.
Oh.
The report mentioned Cagenin. They're leveraging graphs to help pinpoint potential drug candidates for COVID-19 clinical trials.
Wow.
They're examining connections between different biological data types. And then Amgen, they're using graph databases to map networks of healthcare providers.
Okay.
To get a better grasp on those referral patterns.
Okay.
And ultimately to improve patient care.
So it's about finding those hidden links within these really complex biological systems.
Absolutely.
To speed up scientific discovery.
Exactly.
It's pretty amazing, right? From suggesting our next movie to potentially finding life-saving treatments.
Right. The breadth is incredible.
It really is. What about something a little closer to home for a lot of people, social media?
Right. Well, social network analysis is a natural fit for graph technology. Social networks, it's all about relationships, right?
Yeah.
You have individual users as nodes, and their connections, friendships, followers, interactions, are the edges.
Right.
And graph algorithms can analyze the structure of those networks.
Okay.
To identify influential users, detect communities with shared interests, and understand how information spreads.
Okay.
So those platforms themselves, they use this for things like suggesting new connections, recommending content. But it goes beyond the big social media company.
Okay.
Any organization that needs to understand communication, collaboration internally can benefit.
So it's not just the Facebooks and Twitters of the world.
No, not at all.
Any organization dealing with interconnected data could find some really valuable insights there.
Definitely.
Absolutely. Okay, what about risk analysis, for example?
Yeah, great point. Graph algorithms, they can uncover those hidden relationships that might point to potential risks, similar to how they detect fraud. You can identify those risky connections between different entities within a network. And the report even talked about contagious risks.
Okay.
Which is basically how a vulnerability in one part of a system can cascade.
Oh, wow.
And affect other parts.
Okay, so a little concerning, but also super valuable to be able to see that coming.
Right, to be proactive.
To be proactive.
Yeah.
Okay, what other key applications should we be aware of?
So knowledge management and discovery is huge.
Right.
graph technology, especially through knowledge graphs.
Okay.
It's perfectly suited for organizing and connecting information from all sorts of sources.
Okay.
So think of knowledge graphs like webs, right, of entities and their relationships.
Mm-hmm.
And it provides this structured, contextualized understanding of knowledge.
Okay.
And this supercharges AI systems, right?
Okay.
They can better understand natural language.
Mm-hmm.
It improves accuracy and relevance in recommendation engines,
Mm-hmm.
and lets those question-answering systems give much more precise, insightful responses.
So it's not just about the information being there, it's about it being connected and understandable for the AI,
Right.
which then allows for new knowledge, new breakthroughs.
Exactly.
Awesome. Okay, so beyond those core areas, are there other interesting uses emerging?
Oh, absolutely. Tons.
Okay.
We're seeing graph AI applied to supply chain optimization, mapping out those networks,
Okay.
finding bottlenecks
Okay.
in cybersecurity, analyzing network connections for threat detection,
Right.
enterprise content management. It's enabling the creation of semantic graphs for better knowledge management.
Mm-hmm.
Even in the Internet of Things, it's being used to organize and analyze data from all those connected sensors more efficiently. And in material science, researchers are using it to discover completely new materials.
Okay.
By finding these unexpected connections in scientific research, it's so versatile, it's incredible.
Really is. You've painted this really, I don't know, comprehensive picture of all the ways it's being used.
Yeah.
But how does all this amazing capability, how does it translate into actual dollars and cents and new business models?
Yeah, that's the key question, right?
Yeah.
For any emerging technology.
Mm-hmm.
And the report points out several ways that graph AI is doing just that.
Okay.
One big one is AI-powered pricing and promotions.
Okay.
So by analyzing real-time market data, competitive pricing strategies, changes in demand,
Mm-hmm.
and those intricate patterns of customer behavior, all represented as interconnected data points.
Okay.
Sophisticated AI algorithms can determine the optimal price for products and services,
Okay.
and they can tailor promotional activities to get the most bang for your buck.
So instead of those more static pricing models,
Right.
it's like dynamic AI-driven strategies.
Exactly, all based on those connections.
Right.
And another crucial aspect is unifying data and creating what's often called a 360-degree view. So businesses often have valuable data scattered across tons of different systems and databases.
Right.
Graph AI platforms are great at bringing this fragmented data together,
Mm-hmm.
intelligently identifying, linking related entities,
Okay.
and then constructing a comprehensive view of customers' markets' operations.
So breaking down those silos of data
Right.
and seeing that complete picture for the first time
Exactly, by understanding how everything's connected.
makes sense. Okay, what else?
So we're also seeing growth in graph AI consulting and specialized platform services.
Right.
More and more organizations are realizing the potential of this technology.
Right.
And so specialized firms are popping up
Okay.
to offer expertise, powerful tool sets.
Okay.
These offerings range from consulting services that help with those tough data challenges
Mm-hmm.
to developing custom solutions.
Okay.
And then you have platforms like GraphGrid and Graphify
Mm-hmm.
that provide the infrastructure and tools to build and manage those complex deployments.
So it's not just about companies having to build this expertise from scratch in-house.
Right.
They can go to these outside experts,
Exactly.
use these platforms.
Yeah, and a particularly important service is Graph Retrieval Augmented Generation, or GraphRG.
Okay.
It uses graph databases to make data retrieval and content generation more accurate
Mm-hmm.
and relevant for machine learning models,
Okay.
especially powerful stuff.
Cool. Okay, so now we're seeing that there's a clear pathway for businesses to really utilize this technology.
Mm-hmm.
But let's switch gears a bit and talk about how new AI products actually come about.
Okay.
So what role do graph databases and their algorithms play in those early stages of development?
Right, so graph databases, they offer some really cool advantages during that prototyping phase.
Okay.
One big one is their flexibility in data modeling.
Okay.
So early on, your understanding of the data, how it connects, is likely to change, right?
Right.
Graph databases let you adapt your data structure easily, adding new types of nodes or relationships
Mm-hmm.
without those rigid constraints you get with relational databases.
Gotcha.
They're also super efficient at handling complex relationships.
Right.
and that interconnected data we've been talking about.
Makes sense.
Plus, many platforms provide these intuitive visual interfaces.
Okay.
Makes it way easier to query and explore the data, often without needing to code.
Okay.
Datawalk's Universe Viewer is a great example. You can explore complex data without code.
Wow.
And importantly, graph databases often have better query performance for interconnected data
Okay.
compared to relational databases, which speeds up prototyping.
Okay. So it's about being agile, adapting your data model as you learn more,
Right.
easily exploring those connections and getting quick insights during that experimental phase.
Exactly.
Okay. And what are some of the big players in the graph database world?
Right. So there are several platforms that have become really popular for AI development. The report mentions Neo4j, Amazon Neptune, TigerGraph, which is known for its real-time deep link analytics, ArangoDB, it has a multi-model approach, and Datawalk.
Okay.
Many of these offer cloud-based and self-hosted options,
Okay.
giving developers choices.
Great. So what does that typical process of prototyping with graph technology look like, step by step?
Okay, so the typical workflow starts with integrating data from different sources into the database.
Okay.
Then you model the data as a graph, defining those nodes and edges,
Okay.
really tailoring it to your AI problem.
Okay.
Then there's query development, often using languages like Cypher or Gremlin
Okay.
to explore and find patterns. You'll then experiment with different graph algorithms
Okay.
to uncover deeper insights.
Okay.
And often you'll need to integrate those insights with external AI and machine learning frameworks for things like training models.
Okay.
The idea of a minimum viable graph is helpful too. Starting simple, then expanding as you learn.
Right.
And thankfully, most platforms offer SDKs and connectors to streamline that integration.
So it provides that clear roadmap for using graph technology to build new AI solutions.
Yeah.
Awesome. Now let's look ahead.
Okay.
What's the future of graph technology and its impact on the evolution of AI?
Oh, it's super promising. Industry forecasts show a big increase in the adoption of graph tech in AI.
Okay.
Some predictions even say it could triple by 2027.
Wow.
There's this growing recognition that graphs provide that essential context for the next generation of intelligent AI.
Right.
Knowledge graphs, in particular, are seen as key for enabling those advanced reasoning capabilities. The AI software market overall, well, that's projected to keep growing like crazy.
So the experts are basically saying we're about to see a major acceleration in the use of graph technology in AI.
For sure.
Yeah.
And one of the main drivers behind that is the need for better accuracy and deeper contextual understanding in those systems.
Okay.
The future of AI accuracy, it won't just be about spotting patterns on the surface.
Right.
It'll depend on grasping the context.
Okay.
And graph databases and knowledge graphs, they excel at providing that context by explicitly representing the relationships in the data.
Right.
This helps reduce those AI hallucinations and makes AI systems way more reliable.
Okay.
Plus, by understanding those relationships, AI can handle complex queries better because it's interpreting the user's intent more accurately.
That makes a lot of sense. The more context,
Yeah.
the more reliable, the more accurate the AI.
Exactly.
The more trust we can place in it.
Absolutely.
What about these really cutting-edge areas like generative AI, large language models? How does graph technology fit in there?
So the integration with generative AI and large language models is super exciting.
Okay.
We're seeing this rise of graph retrieval augmented generation, or GraphRAG.
Okay.
It's a powerful combination.
Okay.
It leverages the structured knowledge in graph databases to really boost the understanding, the reasoning, and content generation capabilities of those large language models.
Wow.
And then there's this amazing potential for graph-based generative AI to go beyond just analyzing data
Okay.
to actually generating brand new ideas
Okay.
by finding hidden connections within that graph structure.
Wow. Unlocking new levels of creativity and problem solving in AI.
Exactly.
Okay.
And in the future, we might even see real-time adaptive learning in graph databases,
Okay.
so AI can constantly update its knowledge base based on changes in the real world,
Wow.
keeping that information accurate over time.
So we've covered a lot of really cool theoretical stuff, but let's get practical.
Okay.
What industries are going to see the biggest changes from graph AI?
So the impact is going to be widespread.
Okay.
In financial services, we'll see even better fraud detection, more nuanced risk analysis,
Okay.
and truly personalized advice. Healthcare and life sciences, faster drug discovery, more targeted medicine,
Yep.
improved diagnostics.
Okay.
E-commerce and retail, it's hyper-personalization.
Right.
Supply chain optimization.
Okay.
More accurate predictions of what customers will do.
So.
Marketing and advertising, more predictive strategies, real-time personalization of ads,
Okay.
and understanding the whole customer journey.
Okay.
Supply chain management, we're talking autonomous systems.
Wow.
Proactive analysis of disruptions. Telecommunications, proactive network optimization.
Okay.
Personalized services, and predictive maintenance.
Okay.
Even manufacturing, we could see widespread digital twins.
Okay.
Powered by graph data and AI, leading to better production and quality control.
Wow.
Government agencies can use it for better crime analysis, resource allocation. The energy sector for smarter grids.
Okay.
And media and entertainment for super tailored recommendations.
Okay.
Even personalized content creation.
It sounds like there's not a single industry that won't be touched.
Right.
Potentially revolutionized by this tech in the coming years.
It's pretty incredible.
It really is. Okay, but let's take a step back.
Okay.
Make sure we're being balanced. What are the specific advantages of using graph technology compared to other AI approaches?
Okay.
And where might it have limitations?
Right. So Graph AI has some distinct advantages.
Okay.
It's amazing at modeling those complex relationships, and it provides way better contextual understanding
Okay.
compared to methods that treat data as isolated.
Right.
The ability to actually see those connections makes AI decisions much more explainable.
Okay.
It's super efficient for querying interconnected data and can be effective even with smaller data sets because it focuses on the relationships.
Okay.
Graph databases are also very flexible. They adapt to evolving data structures. They allow for faster analysis, getting insights from dynamic relationships, and they're powerful for uncovering those hidden patterns in the data.
Okay, so those are some pretty strong selling points.
Yeah.
What are the limitations, the challenges?
So one challenge can be scalability when dealing with really massive, densely connected graphs.
Okay.
Also, Graph AI relies heavily on good data quality and consistency.
Okay.
And getting data from lots of different sources into that unified graph can be tricky.
Right.
You often need specialized knowledge in graph modeling and query languages,
Okay.
which might be a learning curve for some.
Right.
The upfront costs for building a graph system can also be higher
Okay.
for super simple transactions where relationships aren't a big deal.
Okay.
Graph databases might not be better than relational databases.
Gotcha.
And handling rapidly changing data streams within a graph,
Okay.
that can be tough too. And while graph technology is great at representing those explicit connections, figuring out the implicit knowledge, the stuff not directly shown in the graph, that might need extra techniques.
Okay.
Or integration with other AI methods.
So it's important to be aware of both the strengths and the weaknesses.
Yeah, absolutely.
You know where it shines and where it needs some extra help.
Exactly.
Okay, to wrap things up, can you share some real-world examples of successful graph AI implementations?
Yeah, so in fraud detection, eBay has had great results.
Okay.
They use graph analysis to model user behavior, find anomalies. JP Morgan Chase uses graph tech to get a holistic view of their data, which has led to much better identification of suspicious activity. And Intuit has seen a big jump in their fraud detection rates using graph-based approaches.
Wow.
With recommendation engines, Amazon and Netflix, of course.
Right.
They rely heavily on those user-product interaction graphs. And Michael Kors, they even have an AI assistant on their website that uses graph tech to understand preferences and boost conversions with tailored recommendations.
Okay.
In drug discovery and healthcare, we've talked about Qiagen and their work on potential COVID-19 drugs, and Amgen mapping doctor-patient interaction.
Right.
For customer relationship management, Klarna's GenAI chatbot, Kiki.
Okay.
It's powered by a Neo4j graph database.
Wow.
For more intelligent, contextual customer service, Data offers a GenAI analytics platform built on graph databases.
Okay.
And DECK combines Neo4j and LLM-powered ethnography for deeper customer analysis.
Okay.
Even Microsoft Xbox, they analyze the social connections in gaming communities.
Right.
using Tiger Graph to improve customer loyalty and engagement.
Wow.
And for supply chain optimization, DHL uses knowledge graphs to streamline their logistics.
Okay.
And Intuit uses them for customer insights and fraud prevention within their supply chain.
Those were some really solid examples showcasing the power of Graph AI in action.
Yeah, for sure.
Okay, one last thing. Let's talk about how graph technology intersects with explainable AI and knowledge graphs.
So this is where things get really synergistic.
Okay.
Graph technology naturally enhances AI explainability.
Okay.
You're explicitly showing those relationships.
Mm-hmm.
You can visually trace the reasoning in the graph.
Okay.
So it becomes much easier to understand why an AI made a certain decision.
Okay.
Knowledge graphs are essential for this, particularly in fields like healthcare and finance,
Mm-hmm.
where understanding the why behind an AI's output is crucial.
Right.
Plus, researchers are developing XAI techniques specifically for graph neural networks
Okay.
to pinpoint the most influential factors in a prediction.
So it's not just about getting an answer.
Yeah.
It's about understanding how the AI got there.
Exactly. The reasoning behind it.
Okay.